Well, I guess we are ready to get started today. We have over 40 viewers already and more than 200 people that subscribed, so we are really happy. This is our first webinar. So for those who doesn't know us, I'm CEO at Abstracta. Abstracta is a world leader in software testing and quality assurance, and we focus on improving the performance of software applications. We have been in this business for almost 8 years, helping clients like Verifone, BBA Bank, and Shutterfly who are joining us to improve the processes, select the proper tools to use for testing, and also augment their team with our performance engineers in order to reduce risk and help them to run their systems optimally. So today we're going to talk about continuous performance testing. Melissa Chawla from Performance Engineering team at Shutterfly is joining me. Welcome, Melissa.
Thank you. Glad to be here.
Thank you. I'm thrilled that you are joining us today. Melissa will be talking about how Shutterfly achieves continuous performance testing, and in order to make sure that their customers have a good experience and that it doesn't deteriorate over time with introductions of new functionalities to their system. For those who don't know Shutterfly is one of the market leaders, e-commerce, and have been in the business for many years, and last year they hit their first 1 billion revenue. So they're pretty big, and performance is something critical for them, right? Okay, so let's get started with today's agenda. I'm going to start with a brief introduction on performance testing and continuous. That will be the agile approach that we'll take to say, okay, let's start running performance tests in the beginning of development, and don't wait until the end before you go live to test the performance of your system. Then we'll see what a real-world example. So we'll take Shutterfly example and tell how they are doing this today. And then Melissa will be telling us some of the challenges that they face at Shutterfly, and of course some recommendations that she has for us. And then we'll have a space for questions from you that based on what we've talked. Okay. So let's get started. You might be familiar with this picture, the Firefighters Job, right? Usually what happens is, okay, we have every plan, we're going to release on Friday, and then during the weekend we have our DevOps, sysadmin, and whoever from the infrastructure team that has to stay to solve the last-minute fires. We don't want to be firefighters. We want to be confident that when we go live, our system will perform well. So in order to avoid this, we have to be proactive, and we have to test our system performance earlier. Today, we are going to show you one approach and how you can do this type of testing and integrate this test in a CI scheme. So let's first start with some basic concepts. What's performance testing about? What are we talking about? So performance testing involves analyzing your computer system performance through a simulation. Okay, so we don't want to wait until production to know how the performance of our system is. So we're going to simulate that scenario. During the simulation, we need to do some measurements, because as this guy says, what we don't know is what gets us killed. So we need to measure during the simulation different aspects of the performance in order to be able to detect things like bottlenecks. So bottleneck, in this case, we have a picture of a bottle because it represents, in the case of the software or a system, is the thinner part of our system that doesn't allow it to be faster. Another thing that we want to detect during our performance tests are breaking points. So what's the amount of load that our system is able to handle without degradation. So these are some of the things that we want to be able to detect during our performance test, and that's why we need to measure. So let's go into continuous performance testing. What's the goal of continuous performance testing? Well, one of the main goals is to be able to, we want to be able to detect when something changes in our system, it could be a line of code, it could be a change in configuration or hardware, we want to be able to detect it as soon as possible. That we can identify it right away. It will be easier to fix it, and we don't want to wait until we are in production in order to find this type of problem. And in order to achieve this, we need to run tests before, and there are several ways we can do this. And today we're going to introduce a methodology that will help us run this performance test. So let's see how Shutterfly does it. And before I leave Melissa to tell you all how Shutterfly is working with this today, I'm gonna present some key aspects of Shutterfly's reality. So Shutterfly builds continuously. They run several functional and load tests, some basic regression tests before each commit, and then have full regression tests 2 or 3 times per week, and running acceptance tests before putting a new version in production. And then also different checks with tools like SonarQube, and you can check for security. They have 300 unit load tests. These tests are being developed by developers, built by developers, and these run 3 times per week in their Jenkins, that's the CI server that they're using, and in a dedicated environment. And these tests are the ones that our team, Abstracted team, is working with Shutterfly to help them consolidate and optimize these tests. For example, part of our job is to find which are the right assertions in terms of response times and throughput that we need to put in the tests that are running in the Jenkins. For instance, we have a developer that writes the load test, and they test it with 100 virtual users in their own machine. And our goal as performance engineers is to know what is the amount of, in this case, virtual users that should be running this test in the CI 3 times per week. That will show us when there's certain degradation in terms of response times or throughput. So how are we able to know, for instance, what's the breaking point for that test, right? So these are the questions that we need to ask ourselves, and that's our work as performance engineers. So as I said, we need to have assertions. So these are the acceptance criteria that our test. We look at several. Some of them could be response times and throughput. What we want to know is we want to put these assertions as tight as possible so that the slightest system regression, whatever that is introduced that has a negative impact in the system, our validation will fail, and we know that there's a problem. And I like to call this clinching the belt tight. So we are all the time with our belt tight with these assertions, and if anything changes, we will know it right away. That's the idea behind running the continuous performance test. In order to achieve this, part of the work that we need to do is to do profiling of our load test. So once we get the test from the developer, we need to be able to find where to put these assertions that I was explaining before. And for this is that you do a profile of a test. And that's something that Melissa will explain now.
Sure. So a couple of things to start with. Before you can profile a test, you have to have some place where you're going to run your test. We recommend that you have a dedicated, exclusive environment for performance testing. It takes a lot of work to develop this environment and have it actually be valid for your testing. It needs to be as much like production as possible. It can be scaled down for financial reasons. Ours is definitely a scaled down version of our production. What we do is we have all of the same components in our non-production environment. The exact same level of hardware wherever possible, same memory, same CPUs, but fewer of them. That's the approach that we took. And the idea is that you want your results to be actionable and extrapolate to production, right? If I get this performance in my non-production environment, I can assume I will get that in production. So you have to be careful about assumptions that are linear. A lot of what we're doing is making sure that we understand what the capacity of one host or 2 hosts would be, and then we can extrapolate that capacity-wise to production levels of 100 hosts. So the next step, after you've got this environment that you can test in, you've got somebody developing the actual test case. What we recommend is try to break down your site into chunks, units. The chunks that we break things down into are typically endpoints, web service endpoints. Sometimes, and this depends very much on your use case, we'll have several endpoints that are never used by themselves and they're always used in conjunction together. You can put those in the same test and make sure that you're using them at the appropriate relative ratios to one another that you expect to see in production. In fact, when you have more complex tests, testing several services at once, there's pros and cons there. Then it can be harder to see which of the services is causing the problem, but it is more realistic to what the load is going to be like, so you have to sort of make those judgment calls as you go. But generally speaking, we break things down into smaller pieces because it's easier to detect the root cause of the problem when you're measuring smaller chunks of the system. So typically it's a web service, so for example, retrieving my photo albums on Shutterfly. It's a common thing that our customers need to do. We also test web front-end pages, key pages on our site. So services and pages can be done using this model. So the big question, once you've got your test and your test environment to run against, is how do you figure out the right throughput and the right response time ratios that your service can achieve? We're going to focus very much on throughput and response time. I'm not going to say much more about error rate, except to say that it needs to be less than 1%. And we just make that a rule across the board for all of our tests. And we really just don't even bother to have that conversation. Every test we write has an error, an assertion ensuring that the error rate is less than 1%. And so throughput and response time are sort of the key indicators of the test and where you should focus your energy on getting the test right. And it's actually the hardest part. I just want to spend a moment talking about P95. I don't know if everyone on the call is familiar with the concept, but we do not measure average response time. The reason is that the outliers in both directions can dramatically skew your results. We focus on P95. The 95th percentile response time means that 95% of the requests took X amount of milliseconds or seconds or less. And because we care about all of our customers, or at least 95% of them, that's why we focus on P95. P50 can be useful, also known as median. It's useful to take a look at your median just to understand what percentage of your customers are getting the P95 response time versus, is it 95% of your customers getting that response time, or is it really just the last 10%? And it's sort of helpful, but the measure that we hold ourselves to as a standard is P95 at Shutterfly. So that said,
so here what we have is an example on how to profile a test. Starting with the example that I said before, let's imagine that we have 100 virtual users in our test. And when running the test, we get that our transactions per second are 50, and we get a response time of 100 milliseconds. And then what we do is we'll get that same test and we run it with 200 virtual users. And we see that, okay, transactions per second is scaling. We still have more or less the same response time, so it looks good.
Yeah, so one thing to note, I've had a lot of questions from people asking, where do I start? And that's a tough one, and I got to say, you guess on that one. And what I generally recommend is that you just kind of double your load as you go until you start hitting breaking points, right? If the system falls over, then, falls over, crashes, whatever, obviously you went too far, start picking lower numbers. In this case, we just double it until we get to, and we'll show you what the breaking points look like.
Yes. So we will keep going. We have then 350, 400 users, and that's where we see that the transactions per second are not getting higher, they're not increasing. Right. And then we see that with 450 users, we decrease the amount of transactions per second, so something has happened here, right?
So generally speaking, at some point, if you keep adding load, your throughput will not go up anymore. When you hit that point, we kind of hit that point at 350 to 400 virtual users here. You can see that the curve tops out at, 150 requests per second. That's basically our limit. This system can't do more than that. That's when you maybe go back to your development team and your product management team, you find out like how much throughput do we need to be able to handle? Are we, do we need to add resources? Do we need more hosts? Or are we good? Right? That's sort of a decision to be made. But you have a very clear curve here showing you we can't do more with the hardware that we have. As for response time, it's really also common that you will see that as the throughput doesn't increase as you add more load, your response times usually go up, right? So you're handling the same number of requests more slowly if you put too much load on the system. And so this is an example of sort of seeing how your system handles that more load and deciding where you want to draw that line. Another thing I'll point out is that I said double your load until things go bad. And in this example, we did double the load the first time, and then we started to back off a little bit. You have to decide what makes sense for your service. If 400 virtual users, or actually it's more about throughput than virtual users, if 100 requests per minute is actually more than you needed, there's requests per second, apparently. If that's more than you needed, you have to decide whether you want to push the system to its limits just to see those bottlenecks, or whether you're sort of happy with, hey, we're meeting our goals. I generally recommend pushing the system to its limits. If you're pushing your system to its limits, I don't recommend keeping doubling it. Now you need to sort of back off on that load to see how smaller increments are handled. And this is guesswork. So you build a chart, you look at your curve, and you decide where you want to fill in more data points. And it's kind of a science, it's kind of an art. Okay, so in the next slide, we talk about choosing that final threshold of sort of where is the knee in the curve. In our case, we saw the throughput level off before we saw the response times go up. That is not always the case. With many services, you will see that the response times go bananas, but your throughput is going up, but you probably want to stop before your response times go crazy. So in this case, we saw the knee in the curve at 350 concurrent users, and the response time. So here's another thing that's kind of more of an art than a science. How do we pick what response time to actually put the assert at? It's not a rule of thumb. There isn't really a rule of thumb on this. I would start with maybe a 20% buffer, but that seems really high for a lot of things, where you say, well, we achieved 130 milliseconds, but I don't want to get notified when it goes to 131, right? So we added 20% buffer, and we'll get notified if the response times go higher than that. However, the right thing to do is to run the test, sort of watch it for a couple of weeks, watch it for days. I guess it depends how quickly your test runs, but run it a bunch of times, get a lot of data points. You need to figure out how stable your test is. For us at Shutterfly, we find that some of our tests are extremely stable. Every time they run, they really have the same throughput and response time, and there we can have a really tight assert threshold. We could say if it goes over by 5%, we want to be notified. I don't think we typically go less than 5%, but you have to know sort of how stable that test is. Other services we have fluctuate a lot more, and we don't know why, but they're within our SLA, so we don't mind, and so we just give ourselves a bigger buffer there. We don't want tests to be noisy. We don't want tests to alert us and say, I'm failing every other day, but not be actionable. Meaning the engineer gets the message that their test is failing every other day, and they're like, but there's no problem. We don't have a problem. I'm not going to look at this. I don't have time to look at this. And they learn to ignore the alert, and they get alarm fatigue. That's a real thing. And so that's a noisy test, and it's basically lost its value. So setting those thresholds is extremely important, such that the test is not too noisy, but will let you know when you actually have a degradation.
Perfect. So what's the main result of this methodology? Well, basically, the main idea is that the day that the performance of, in this case, the functionality which was retrieving my photo album is great, it will be possible to detect that as soon as possible. And that's what we want from running continuous performance tests. And also going back to my first slide, okay, and the main result is that we avoid being firefighters, right? We avoid having to stay up late when we go live and everyone is super worried about what's happening. So we are confident that we are releasing and that performance won't be affected. So let me ask you, I have some questions for you, Melissa, regarding how you're doing this at Shutterfly in terms of tools. So what type of tools are you using to run the test, to analyze the results?
Yeah, so we've been using Gatling at Shutterfly for about 3 years now. We're really enjoying it. It scales beautifully. For all of our non-production needs, we have one host generating load, and we don't need to coordinate multiple hosts. There isn't a big cost to that. For us, Gatling's pretty quick and easy to pick up. It's an open source tool. It's a bit like JMeter, but this is not a record and replay tool. This is scripting. It's in Scala, but that's interoperable with Java. If you're familiar with Java, you can do this pretty easily. And also, thing to note is that load tests are not a lot of code. The planning, the effort in load testing is never the coding. There are a few library calls you're going to make. Planning the data sets for your tests, figuring out your throughput threshold, analyzing the system when the tests are not passing. That's your cost. So you gotta think about the cost of this whole program as being the sum of owning all your tools and the willingness to analyze the system and also having the right skill set and the right people involved to be able to properly analyze the system when your tests fail. Right? Developing the test is the smaller cost here. And I think a lot of people overlook the cost of ownership and only think about the development costs. So we felt like Gatling was a good choice. Really quick test development with Gatling. And it's quite stable. We've not had bugs or problems with that as load generation tool. We use Jenkins for our continuous delivery, so that was the obvious choice for our test execution as well. One note about Jenkins, the way that we use Jenkins that's kind of special is that we use a labeling mechanism, it's called throttle concurrent categories, I believe, for ensuring that our tests run in a queue one at a time. We don't want load tests to run at the same time as each other because they're all hitting the same test environment, at least for us at Shutterfly. And we don't want them to interfere with each other because even if the tests are hitting two different endpoints or web pages, there are a lot of back-end systems that are shared resources. The network, the databases, the load balancers, and we can't have that noise and the uncertainty of one test interfering with another. And so Jenkins has been a great platform for us to use as a queue and also integrate really well with our build. So when we build the final deployment of the software, we deploy the software into our test environment, and then we kick off a series of benchmark tests to make sure that the sort of web applications are even responding, not even hitting our web services, but just ping and functioning well. And then we hit our load test, and we're running them 24/7. We are also using Graphite, also open source. Oh, do you notice a pattern? Everything here is open source. Graphite's our database for storing the test results. We're not just storing pass fail and what tests ran and when, we're also storing the response time and the throughputs met, and we're able to use Grafana front end for Graphite, also open source, as a way to sort of graph the trend of our tests over time. So Gatling has inbuilt this concept of a cert, so your test can fail when it doesn't meet certain thresholds, and that's sort of inbuilt to Gatling, and it is very easy to operate that and integrate that with Jenkins so that Jenkins' job will actually fail when the Gatling test asserts that the thresholds aren't met. And in addition to that, we're sending, using the Gatling plugin, also open source, Gatling plugin to Jenkins. We have customized it to suit our own personal and private needs at Shutterfly, but I think we're using most of the vanilla features there of that plugin. That's sending data to Graphite database, and then we're able to look at the trend of our test over time. So even if it's been passing, how stable is it? We get to look at it visually. It's super convenient. Another tool that we're using at Shutterfly is not connected in any way to Gatling or Jenkins or Graphite just yet, but it's App Dynamics, and it's just a complement to our load testing. It's the tool we use to go and look at traces taken during the test run. So if the test is failing, The idea is what kind of visibility do we have and how quickly can we diagnose the root cause of the problem? And right now we're primarily looking at app dynamics for that. We're talking about also trying to integrate it better and more tightly with our test results so that it takes you right to app dynamics and right to traces that are interesting, just as a convenience. We're also looking at maybe JProfiler and integrating that somehow.
So let me ask you some of the challenges you face, because all this sounds great, but I'm sure that you did have some challenges to make all this happen, right?
Sure, absolutely. Hands down, biggest challenge is the signal to noise ratio. Keeping that low on load tests is really, really hard. But here are a few things that you can do to help. Make sure that who's ever maintaining your test environment is not doing what I call drive-by shooting. They can't just go change the environment without any kind of tracking or notification. They've got to be tracking it the way that they track production changes, right? So we've certainly had many instances in the past at Shutterfly where, oh, this is not a production system, I can do whatever I want. And people would go changing hardware, changing stuff, bringing stuff down, and you have no idea why your tests are failing. And somebody's actually doing something and causing it, and it's a big waste of time. And so what we did at Shutterfly was we tightened up that process, and we have tickets filed for maintenance work being done on our non-production environment, the same way we do for production. And that's really saved a lot of time for all of QA at Shutterfly. Yes, other challenges. Adoption of a program like this is always going to be a challenge. I don't think that QA organizations can or should do this in a vacuum. That's not how we're doing it at Shutterfly for sure. The development teams own the load tests that they develop, and my team, performance engineering, we own the framework, we own the infrastructure and the tooling, and we train those teams on how to do this, and we advise them, and we'll even review their tests and go over their test plans with them, kind of like an internal consulting organization that way. But they need to own the performance, and the developers who know the code and know that they have that domain knowledge should be the ones looking at the traces when the tests are not performing. That said, so it's definitely a partnership. My feeling is that this can't work if QA is completely divorced from development. That said, I take it on my team to notice global trends. So one of the goals that I have is that, we have a lot of pieces of our system that can become less performant. We want to notice the ones that are global to all the tests. If the load balancer is not working right, if there's a networking problem, it's affecting a lot of tests, my team will notice stuff like that. So that the individual contributors, the developers, don't get tickets, like 30 of them get a ticket about their individual area and go research it only to find out that there's a system problem that isn't theirs. Those are the kinds of things that you can do to mitigate the signal to noise ratio problem. Trust your results. That is a challenge. I don't know how many folks on the phone are listening in QA and have had many experiences where people blame the tool before they blame the actual system under test. I certainly have had that a lot. One way to reduce that is to reduce that signal to noise ratio, right? If your test, 50% of the failures indicate a problem in the test, people will be dying to blame your test. If you only bring to the developers the problems that really are theirs, you're a rock star. And it's probably impossible for that to be 100% right, but if you strive to have a 90% ratio, you don't want to bring stuff to engineers that is really our problem.
So let's go now to some final recommendations, Melissa, that maybe you can share with us based on your experience and what you have been doing here at Shutterfly.
I think one of the critical pieces for trusting your results is actually seeing them. It's really easy for people to automate tests and then ignore them when they fail. I think probably everybody can agree that that's happened one or two times. We definitely want the test to have automatic feedback. We're still working on how to get people to pay closer attention to that as part of their development process so that they don't release a code change when they forgot to check whether their test was passing. Part of the reason this is maybe harder, it's not as continuous as we'd like it, because when we're load testing, like I said, we've got one environment for that at Shutterfly, and all the tests, they get in the queue one at a time. It's not realistic to expect a load test to run after every change gets checked in. there aren't enough hours in the day for that to happen. It's just impossible. We don't even do builds after every single check-in. In a lot of our codes, it's more like daily builds. And we do daily deployment, and then we run a batch of tests. And so we have to be very disciplined at Shutterfly to remember to check the test results and interrupt them and to not explain them away before we release it. So I think I mentioned this before. Don't expect that your cost is only in developing the test. In fact, if you develop the test and then you don't expect to revisit that test, the test will become useless very, very quickly, possibly more so than your average functional test. The reason is that improvements happen actually all the time. Our ops department is always upgrading some piece of hardware and almost always improving performance with it, which is great. That's a great problem to have. But when they improve the performance and you don't revisit your tests, all of a sudden what you start to see is your tests are performing better than they were before. The trends show it because you've got maybe improved hardware. And if somebody checks in a bad change, they start making a really heavy database call that they shouldn't, you won't see it. It may double or triple the response time, but your test won't complain because the cert thresholds are too high. You got to be sort of watching those trends, even when there isn't a problem, even when the tests are passing, your test might be quietly useless. Or like I like to call it, tests are like fish in a bowl. You have to keep feeding them or they die. And when fish die in a bowl, they stink. So another really important point I want to make is that this does not replace production testing. We still need production testing at Shutterfly because our production systems are in some ways different from and will always be different from non-production systems. Things that you might find in production testing, even if you do the most bang-up job, awesome job non-production testing, still have to test in production because you will find configuration problems, load balancer problems, that's a favorite, switch, networking, infrastructure problems. We found CDN problems. My company switched CDN providers because of the production testing we did at scale. So when I test in non-production, it is not quite at scale because depending on what your site is like and whether or not you're in the cloud, we're not entirely in the cloud at Shutterfly. We are partially in the cloud. We can't have a non-production system as big. Right? It's got to be all scaled back. So the production testing is absolutely critical for us. But here's where you win, because what I'm proposing is you can double the testing. Now you've got to do non-production and production testing. And the tools are different and the people are different. The benefits you get from doing this sort of two-pronged approach are that you learn about your problems sooner if you test in non-production. Closer to when the code or system infrastructure change is made, you get to find out about the regression. That's one. Two, when you have 40 people on a call in the middle of the night watching a load test happen against production and you find one problem and it blocks the entire test, and then they take a week to fix that and then you got to test again, you will never be ready for your peak production period because you're iterating too slowly, and many of the problems that you could be finding in production in that very expensive production testing, you could have found in non-production. And so that's the reason to have this sort of two-pronged approach.
Great. Well, thank you so much, Melissa, for your recommendations and for sharing with us the challenges that you face at Shutterfly. Now we have some time for questions from the attendees based on what we should share with you. Okay, they just answer about Graphite. What was the name of the tool?
So Graphite is the database.
Okay.
And Grafana spelled G-R. Graphite has its own front end, which may also be great. I mean, these are just the tools we picked. To be honest with you, I'm sure there are other choices that also work great.
So I was calling with a question. Okay, I know anyone has a question. We received some questions before the webinar that we might answer now. So we have a question that says, can you please let us know how you're doing the part continuous in this model, where and how?
Certainly complicated. So at Shutterfly, I think I mentioned we build daily. Actually, it's way more complicated than that. We have a lot of different pieces of our system that we build at different cadences. That's the truth. The oldest, biggest piece of the system, the most legacy piece, is built daily. Other pieces are built from after every single check-in. But the test environment that we have is sort of guarded and blocked. We don't deploy to it every 3 seconds. We need it to be stable. So we set it up to deploy exactly once a day with whatever's been built for every single code module. It just gets a full daily update. And that way we know exactly when that's going to happen, and we're in very much control about sort of what changed and when. The other thing is that we don't want servers restarting, some servers restarting, others not while a test is running. So we do no testing during the deployment. After the deployment, part of our deployment process is a small handful of functional tests. Don't load test a system that isn't known to be functioning, because you get a bunch of junk. You get 100% failures. Someone will see that automated message saying their test failed, and they'll go look at it and be like, wasted my time. So we want to know that the environment is functioning. We want to know that basic functional tests are passing, not a full regression. Then we run some benchmarks. I believe I mentioned that. We sort of, once the deployment is healthy, once those functional tests are run, we run some benchmark tests that my team has developed. They hit the various different server pools just to make sure that without the code, everything's working great. Then we run sort of one test at a time through the queue until the next deployment happens the following day. I hope that answers the question.
Perfect. We have another question here. It says, is code profiling a part of the continuous testing you're doing at Shutterfly?
Good question. I think that code profiling is done kind of on an as-needed basis. When a test fails, that would be a good time to profile your code. I know that many of our developers will profile the code running right on their desktop before they check it in. When you say code profiling, I'm not sure exactly what you mean, if you're talking about step-by-step through like JProfiler, or maybe you're talking about Sonar. We do have Sonar set up at Shutterfly. I think I would call that also out of band, just like load testing is kind of out of band. We trigger it based on the build, but we don't wait for it to finish in order for there to be sort of further continuous delivery. And the truth is that Shutterfly has not had a continuous delivery model yet. We don't have code that gets checked in and goes all the way through the funnel to production without human intervention. We're not there yet. Humans make a call about when to press the button and actually push stuff out to production. And hopefully they're checking the Sonar results, and hopefully they're checking the load testing results before but it's not fully automated yet.
Okay. We have another question. Can you share some common problems you find with this strategy? Sure.
There's always pressure to release stuff, and there's always pressure to reduce those development cycles. And so there's pressure to not look at test results and not react to them and to explain away failed tests. So we're always combating that pressure for sure. But we find that we can make a lot of really great success stories out of examples of, hey, guess what we just found and did not get to production, did not allow it to get to production. And remind people, so that's my job within Shutterfly, to find those awesome case studies and get the word out that we saved somebody's bacon. We just avoided this kind of outage. There's always a balance there.
Great. I'm having a lot of questions. One from Ram. With Agile methodology, the end-to-end functionality may not be available in some cases. So how are you testing a navigation, for instance?
It's really case-by-case basis. That's very hard for me to answer. I mean, in our non-production environment, I will admit that there are certain pieces of functionality that are not there. They're not implemented on the hardware end of things for cost reasons or whatever. And there are blind spots we have. We can't test those in non-production at all. And the cost there is basically pushed due to production testing. That's the only place we have to do it. That's a judgment to be made, based on the cost. And if you're talking about how do we work around that, we test the parts we can test.
That makes sense. During checking progress, how Jenkins would differentiate between code that needs continuous testing or not?
We don't make any judgments like that. That would be extremely difficult for us to do. We just test daily, and we don't differentiate and say these sections of the system change, so we're going to run these tests. That would be great. We're just not there yet. There are ideas around that at Shutterfly. We're just not there yet, and we don't even have enough time in the day to run. I mean, there's a good problem to have. We don't have enough cycles in the day to run all the tests that we have. So we don't even run all our tests every day. We can't because it's a single environment, and it's a cost issue. What if we made another one? Well, we've decided we don't have that cost at our disposal, and we're good with, typically for most of the tests we run 3 times a week. Some of the things are more back burner. We run them once a week. So the way, I guess to answer your question, we make a judgment, my team makes a judgment call about which things we know are under construction and which things are kind of in maintenance mode and not under construction, and we put those in the Sunday bills. The Sunday tests are generally very stable and not under construction, and that's kind of just how we do it, and so it's not based on what changed. I'll say this though, in my experience, if I had a dime for every single person, and developers especially, who told me, we didn't change that. Your tests are failing. Oh, but we didn't change that. And then we find out what changed, okay? People think things are in maintenance mode that aren't. Or they depend on something that isn't in maintenance mode that changed. And suddenly they find out through our testing, so that means the testing is effective, that they actually, something that used to work doesn't work anymore, and they're forced to make a change. They may not be happy that they have to make a change, but at least we found it before it went to production. That's right. So actually, in my experience, it's great to have that optimization and say we want to super test the stuff that's really under construction, but don't believe people when they say it's in maintenance mode. Don't trust that.
Perfect. And one question from Mark. What if there are no tests in the Jenkins queue? Do you just repeat tests over and over?
Yep.
Okay.
It costs us nothing.
Mm-hmm.
Worst case scenario, you're getting more data points in your trend chart. And they show that your test is stable and it's all good. Cost me nothing. I should point out something because in the past year, talking to a lot of people with a lot of experience with Load Runner, a lot of these guys have the mindset that tests have to be babysat. Jenkins is my babysitter. We do not watch tests run except in very rare circumstances. When we know a test is having a problem, we may then run it again and have people watch a certain subsystem. Normally what we do is make sure that we're pulling all the right data and we have all the right metrics and monitoring in place. These tests are running 24/7. I don't have operators watching stuff 24/7. I don't have the staff to do that. I don't have the inclination to do that. I want machines to do that for me, and that is what we have.
Who usually defines the requirements for an acceptance level for throughput or response time for an application? It is usually business, the tech team, both.
All of the above. In some cases, our business partners are awesome at knowing what throughput thresholds and response times they expect, and they state those clearly, and they won't ship if we fall below them. In most cases, we're fuzzier than that, and some of our business partners don't know what they want, and then it's kind of a work in progress. It's sort of a question about ops and what they can supply and support and development. I think a lot of times we run into a really tough trade-off where, and I'm pretty sure this is a pattern at every company, where ops says, well, if the developers made the code more efficient, we wouldn't need all these hardware resources. And the developers say, we have another project to work on and we don't have time for this, and just give us more hardware. That's common. I fully want to step out of that whole, QA should not be involved in that discussion. QA should step back and let those people figure it out. And our job, the way I see it, is we're auditors. We are just saying, given what you have today, here's what's going to happen when we have peak load, right? And I don't want to get involved in that recommendation because I don't think there is a right answer. I think it's totally a trade-off. And there are two organizations with, you could say, different financial and resource pots that have to go kind of duke it out.
Great. And then regarding the tools that we should mention, apart from being open source, except from Dynamics, what do you see as extra benefits from using those tools? What did you actually choose them?
I'm sorry, what was the first part of that? I missed that.
So yeah, besides, what are the benefits of the tools that we should show besides being open source and they're code free?
Yes, they're scalable. I mean, we've never had a problem generating enough load with Gatling. They're scalable. For me, another important piece, and maybe Gatling is starting to really pick up. 3 years ago was Crazy Fringe, but we picked it because it scales way better than JMeter. JMeter's since improved a lot. Picking tools that are the industry standards is important because you want to hire people who either have that skill set or want to build that skill set, right? If you're using a dinosaur application that nobody wants to have on their resume anymore, that's tough. Jenkins is kind of an industry standard. If you're in the cloud, there are way newer, better choices. So I'm not standing here saying Jenkins is the way. Jenkins is what we were already using, so it just made sense. I didn't really have a choice. I don't always love Jenkins. I'm still standing by Gatling 3 years later saying this has been a great, great tool. We don't expect to hire people who know it because it is not as popular as JMeter, but I expect to hire technical people who want to learn it and can learn it because it's not hard to learn. It's just another technology. And the skill set required to build and maintain and do load testing effectively transcends the tool you're using.
We have a lot of questions and a few minutes left. I'm just going to pick one, the last one, and then please you can all forward the questions to us, and we are going to be able to answer them after the webinar. So the last question is about the importance of how does the management understand the benefits and the value of doing continuous performance testing. It's something that they get it, they don't get it.
I won't lie. A good disaster raises awareness. Unfortunately, some folks won't take action or fund efforts until they've had an absolute disaster in production. We've had a few at Shutterfly, but I'll say this, we have a new CEO, he comes to us from Amazon, they care about performance. Whew, this is great. Not just performance because we didn't perform well, but performance for the sake of performance. Like as in, it would be embarrassing to run a website that was ridiculously slow. And so when upper management cares deeply about this, that does make your job easier. When upper management just doesn't know about it, right? It's not that they don't care, it's that they just don't know how important it is, and they're sort of everyone's crossing their fingers saying, yeah, we'll be fine, but they haven't actually done the testing. Typically, you're going to end up with a disaster, and then you need to ride that wave. Capitalize on whatever failure happened in the last peak and show how you're going to avoid that. The downside there is that disasters can happen even if you're prepared like mad, and luckily my boss and my boss's boss actually do understand that. There can still be a massive glitch outage. There can be things that are unmitigated despite your most awesome efforts. So none of this is perfect, but I think one of the key things is making sure that you have somebody in your organization who's got a megaphone and knows how to use the right language to get to those business people and explain to them what problems we averted. Don't just quietly avert the problems and expect a giant thank you. That will never come, right? You need to kind of PR this effort in time.
That makes sense. Yeah. So thank you all for your questions, and of course, if you have more, you can please forward to us, and Melissa will be able to reply them in email. Before we leave, I want to give you some references. We have a very active blog. You can go to abstracta.us/knowledge center, and you'll find a lovely post that we did about everything that we talked today about continuous performance testing. We have also a review of Gatling that we did, and also about JMeter, which are two of the tools that we use at Abstracta for load testing. So I want to thank you all for joining us today, and of course, Melissa, we are actually doing this webinar from Shutterfly offices in Redwood City, California.
And I want to thank Abstracta for helping Shutterfly this whole season. We've had an engineer at Abstracta who's been instrumental in sort of watching our tests, making sure they're passing, doing the test maintenance that I spoke of, and doing a really great job at it to help us, in this big effort.
Thank you so much, all. And please, we're going to share this video with you all. And if you have any more questions, we'll be able to reply later. Have a great Friday, and we'll see each other again. Thank you.
Thanks, everybody.